everyone. My name is N.T. Mahlangu. I'm a mathematics lecturer at Nkangala TVET College in Mpumalanga. Today, our lesson will be based on exponents. I decided to do exponents because after marking the first assignment of my students, I realized that most of them, they struggle to apply the exponential laws. And this content is very important because when they reach level 3 and level 4, they'll be dealing with calculus. And in calculus, you won't make it if you do not know the exponential laws. Right. Let me start by explaining the importance of exponents. Exponents are important because then they enable a person to shorten very big numbers and very small numbers. For instance, the number 32 can also be written as 2 multiplied by 2 multiplied by 2 multiplied by 2 and another 2. So now this number is big at the moment. So it can be written or it can be shortened and it can be written in exponential form, which is 2 to the exponent 5. Before we can be able to simplify the exponential expressions, we need to know the exponential laws. So we are going to quickly recap on the exponential laws that we are going to apply when we solve our expressions. And in another section, in chapter 2, you are going to solve equations which are based on exponents or exponential equations. Hence, you must know the exponential laws. Laws of exponents. I'm going to write all my laws that side. Before I explain them, you need to know all the names of the parts of a term. Right here, I have written one term of an expression. This is one term. We have negative 3x squared. Remember, terms are separated by either an addition or a subtraction sign. So here, between your 3 and your x, there is no addition or subtraction sign. Hence, this is one term. So, negative 3 represents the coefficient of x squared. And then x is called the base. 2 is called the exponent. Remember, I just said this whole thing is an expression. And then this part is what we call our power. Right. Let's proceed to the laws of exponents. Law number 1. We are going to use z as our base. So law number 1, if you have a multiplication sign between two similar bases, the law of exponent says you write the common base and you add the exponents. Remember, if an exponent is not written, it simply means that there is a 1. So our answer here will be z to the exponent 3. And then we proceed to the second law. I'm going to use z exponent 4 divided by z exponent 7. We are still having similar bases, but the difference now is that we have a division sign between our similar bases. The law says if you have a division sign between similar bases, you subtract the exponents. You must be careful now. You are not going to say because 7 is greater than 4, hence I must subtract 4 from 7. That is not how we do it. The one that appears first, you are going to write it as your first exponent, then you subtract from it the second or the exponent that follows after. And then here we'll be left with z to the exponent negative 3. If you subtract a bigger number from a smaller number, you get a negative sign as your answer. And then another law, I'm going to explain the next law. Another law, you must be able to change from a negative sign to a positive sign. If your exponent is a negative, maybe in a question paper they might say simplify the following expression, leave your answers with positive exponents. You must be able to change from a negative exponent to a positive exponent. So if you want to change from a negative exponent, you apply a fraction, you change the whole thing, you write it in fraction form. Your numerator is always 1. You always use numerator 1, and then you write your base with a positive exponent now. So far here I have explained 3 laws. Then we proceed to the next law. Let's say we have z to the power 2 inside the bracket, and then outside the bracket we have exponent 3. With this one, the one that lies inside the bracket, we have the base and the exponent. But outside the bracket, we do not have the base. So to simplify this one, we are not going to apply law number 1. What you do is, you write the base that is there, and then you multiply the exponent that lies outside the bracket by the exponent that is inside the bracket. Hence, we are going to have 2 multiplied by 3. And then we'll have z to the exponent 6. This is how we simplify this one. And then I'm going to give you more examples on law number 4. I'll write this one as law number 4a. Say maybe inside the bracket, I have z exponent 5 and m exponent 6. Outside the bracket, I have exponent 3. What does this mean? It means that all the exponents which lies inside the bracket, they must be affected by the exponent which is outside. It's going to be z exponent 5 multiplied by exponent 3 and m exponent 6 multiplied by exponent 3. Our final answer will be z exponent 15, m exponent 18. Another one based on the one where we have an exponent outside the bracket. I'm going to write this in fraction form now, or I'll use a fraction as an example. Z exponent 5 will be my numerator, m exponent 6 will be my denominator. And then outside the bracket, I write 3 again. The question is still the same. I want to simplify that expression. I'm going to apply the same law because outside the bracket, I have an exponent which does not have a base. So to open the bracket, I will simply multiply 5 by exponent 3 divided by m exponent 6. I multiply it by 3 also. And then my final answer again here, it's z exponent 15 over m exponent 18. Let's take one more example based on law number 4. I said this is 4a. This will be 4b. Let me write one more example based on this one. Let's say I have z exponent 8 over m exponent 3, all multiplied by exponent 2, exponent negative 2, sorry. In this case, the exponent which lies outside the bracket is a negative. It's up to you. If you want to, you can simply open the bracket using the method that I have explained here. Or alternatively, you can change from a negative exponent to a positive exponent first. If you decide to do so, you are going to rearrange your fraction. Remember, I said if we decide to change to a positive exponent, our fraction now, the status of the fraction will change. The denominator will become my numerator, and the numerator will now become the denominator. And then from this step, you can open the bracket. You simply multiply the outside exponent by the inside exponents. I'm going to stop there with this law. And then I proceed to the next law. I'm going to write it as law number 5. Z to the exponent 0. Z to the exponent 0, you don't have to crack your head. Any number to the exponent 0 is 1. Even if you can have 1000 to the exponent 0, you simply write 1 as your answer. Let's proceed. Another law. You must be able to change from, let's say I have 6 here, cube root of z to the exponent 6. You must be able to change from root form to exponential form in order for you to be able to simplify expressions. How do we do that? What lies inside the root sign? I write it inside the bracket, and then outside the bracket, I'm changing from a root sign to exponential. So this will be now z exponent 6, and then outside the bracket, I'm going to have 1 over 3. And then from this stage, you can apply law number 4, which is to multiply the two exponents. So it will be z6 multiplied by 1 over 3. And then it's z6 divided by 3. It gives us z exponent 2. That is our answer. Right. I think I have covered all the exponential laws for level 2. Now I want us to take examples to see how exactly do we apply the exponential laws which I have just explained. The textbook that I'm using today is published by Macmillan, NCV level 2. We are on page 26. The question is simplify the following expressions using exponential laws and leave your answers with positive exponents. Our first example, it's 3 squared multiplied by 3 exponent 5 divided by 3 exponent 3. The question is simplify. Here we have 3 bases. Our bases are the same. We have base 3, and then we have a multiplication sign and a division sign between our bases. We want to simplify the expression. The law that we are going to apply here is law number 1, because we have a multiplication sign between similar bases. And then when we are through with applying law number 1, we will apply law number 2 because of the division sign between similar bases. So this is how we write our first step. We write the common base. We add 2 and 5 because there is a multiplication sign between the similar bases. We bring down divided by 3 exponent 3. And then we simplify this part first. Hence we have 3 exponent 7 divided by 3 exponent 3. And then we proceed. We have a division sign between similar bases. We apply law 2 now. It's 3 exponent 7. We subtract 3. And then we are left with 3 exponent 4 as our answer. But if you want to, you can proceed to write your final answer as 81. Remember, 3 exponent 4 is not 3 multiplied by 4, but 3 exponent 4 is equal to 3 multiplied by 3 multiplied by 3 multiplied by 3. This is a mistake that most of our students commit when they simplify exponents. Okay. Let's take one more example. 8 x squared y divided by 12x y squared. This is example number 2. The question is still the same. Simplify using exponential laws. Right. We check our numbers first. In our numerator we have 8, and in the denominator we have 12. If you want to, you can factorize 8 in order for us to have similar bases. 8 can be written as 2 multiplied by 4 exponent 1. 2 also has exponent 1, but you don't have to write exponent 1. And then we also have x squared y over, to factorize 12, we can write it as 3 multiplied by 4 xy squared. Right. Let's proceed. We check if we have similar bases after we have factorized our coefficients. There are different methods that you can use. 2 and 3, they are different. So you cannot add their exponents. You cannot work them out with 4 and 4 because they are not similar bases. Hence, we cannot apply the exponential laws. So for now, I'm going to take everything to the numerator. I want to do away with the fractions. So this can be written now as 2 multiplied by 4 multiplied by x squared multiplied by y. And then I want to take this to the numerator. Multiplied by, currently, my 3 has exponent 1. So if I take it up to the numerator, it will change. I'm going to write it with a negative exponent. And then 4 also has exponent 1. If I write it in the numerator, it will become 4 exponent negative 1. X also, I take it up, it will be x exponent negative 1. Y squared, if I take it up, it will be written as y exponent negative 2. As you can see, I said I want to change the step. I do not want to have a fraction anymore. Now that everything has been written in the numerator, I'm going to simply apply the exponential laws. I start with 2. 4 can be changed and written as base 2 exponent 2. 2 multiplied by 2 squared multiplied by x squared multiplied by y multiplied by 3 exponent negative 1 multiplied by 2 exponent 2. Already here I have exponent negative 1. So this is the same as 2 exponent 2, and I already have negative 1. So I multiply this 2. Hence I'm going to have 4 exponent negative 2 for this one, multiplied by x negative 1 and y exponent negative 2. Right. I have similar bases. My first base is 2 exponent 1. I have a multiplication sign between these two similar bases. Hence, I'm going to add the exponent. So it will be 1 plus 2. And then I'm going to look for another base 2. Here it is. It has exponent negative 2. Remember, if there is a multiplication sign between similar bases, we add the exponents. We do not change the signs. So I'm going to write negative 2 as it is. This is the same as plus negative 2, and plus multiplied by negative, it's negative. I have written all my 2's, and then I proceed to the next number, which is 3. There is no other base 3. Hence, I bring down this one as it is. As it is, it's 3 exponent negative 1. And then I proceed now to my variables. I have x as my first base and another x. And between these two similar bases, there is a multiplication sign. So I'm going to write the common base, which is x, and then I add my exponents. So it's x exponent 2 plus into negative 1. It's x exponent 2 minus 1. And then the next base, it's base y. I have a multiplication sign between these two y's. Hence, I'm going to add my exponents. I'm not changing any sign. It's 1 minus 2. And then I add or subtract my numbers. Base 2, 1 plus 2, it's 3. Minus 2, I'm left with exponent 1. Multiplied by 3 exponent negative 1. Multiplied by x exponent 1, because 2 minus 1, it's 1. And y exponent 1 minus 2, it's a negative 1. Remember, when you subtract a bigger number from a small number, you always get a negative sign. I need more space to write on. I'll erase this part. This is the step that we are having currently. We are left with 2 multiplied by 3 exponent negative 1, x and y exponent negative 1. Remember, the instruction here stated clearly that we must leave our answers with positive exponents. So we cannot say we are done. We need to change exponent negative 1 and exponent 1 to positive exponents. Hence, my next step will be 2 multiplied by, I'm going to change exponent -1 there, where the base is 3. Remember I said, if you want to do that, you introduce a fraction with the numerator 1, your base becomes the denominator with a positive exponent now. This is the exponent that we have changed. Remember here it was a -1. This side we have written it with a positive sign because we have introduced a fraction. That is how you change from a negative exponent to a positive exponent. It's law number, I have explained it here somewhere. Which one is it? It's here. I have explained it and I wrote it as law number 3. Let's proceed. Multiplied by, we have x exponent +1, so we write it as x exponent +1, or you don't have to indicate the exponent if it is 1. And multiplied by, our exponent here is a negative. We must change it to a positive exponent. Hence, we introduce a fraction also with numerator 1, and then we write our base as the denominator with a positive exponent now. Let's simplify this further. We have a multiplication sign. Remember, if you have a multiplication sign, even if you have different variables, you are allowed to combine them and write one term. So I'm going to multiply now. 2 times 1 times x times 1, it gives us positive 2x. And then I'm going to multiply in the denominator now. 1 times 3 times 1 times 1, it gives us 3y. This is the final answer. We have simplified the expression using the exponential laws. So far, I can say in this example, I have applied law number 1, law number 2, and law number 3. Hopefully next time, we will proceed and do examples based on other laws of exponents. This is it for today. Thank you.